Everyone, welcome to today's workshop on cloud native application lifecycle management. Today, we're going to discuss some problems people face while managing their workloads on top of Kubernetes. And through the course of the workshop, we hope that you guys will pick up some new tools that might help you in your workflows. And we'll also be sort of teaching you how to distribute these workflows reliably. So let's just go over the agenda of the workshop first. So we're going to start off by identifying some of these problems which people face while managing and distributing cloud native applications. And we're going to be specific to Kubernetes. Then we're going to explore how some of the tools that are part of the Carvel toolset address these issues. And then we're going to get our hands dirty. We're going to pop our terminals out and sort of get some hands-on experience using these tools. And it'll be really cool if you guys can like sort of follow along with us on while we're doing that. It'll sort of help you understand what's going on better. Before we go any further, like quick introductions. I'm Soumik Majumdar. I work with the Carvel team at VMware. So most of my work has been about helping developers deploy their resources and workloads on Kubernetes safely and confidently, and sort of helping them package these workloads and version them and deliver them to the users in a manner which lets them configure it and then deploy it on their own environments. Praveen, do you want to do a quick intro as well?
Sure. Thank you, Soumik. Hi, everyone. I'm Praveen, and I'm also working at Carvel team at VMware. And it has been a great experience working in the open source community. Like we directly get to get feedback from users, and we are able to provide them with solutions and fix issues. Before joining the open source community, I used to develop microservices in Go and used to deploy them on Kubernetes using kubectl. Yep, that's it.
You guys want to sort of drop in what you all do and what kind of work you do in the chat box? That'll be super cool. Please go ahead and do that if you want to. So now I'm going to start off and talk about some of these problems we are talking about, right? But before we jump into that, we would like to know how you all have used Kubernetes so far. Like, I think Girish and a few other people actually shared how they've been using Kubernetes in their organizations. It'll be super cool to get to know how you all are doing it as well. So if anyone wants to maybe unmute and speak up, just raise your hands and we can go out from there.
Maybe I'll share it. So at Cloudega, we use basically Kubernetes to run our hands-on lab. So we provide hands-on lab for the end user in the collaborative space. And that we run on top of Kubernetes. And currently our workflow is pretty straightforward. We just have GitHub pipelines, which we have configured. Mm-hmm. And as soon as we kind of do a code check-in, the pipeline runs, and then we have a deployment staging and production. So it's pretty straightforward right now, not too many complications. But of course, we want to hear more alternatives, what we can have with the tool Carvel. Yeah.
That's really cool. Thanks for sharing. Girish, so we have had a lot of new people join. Would you mind going over how you've been using Kubernetes?
So we have an application which is a microservice-based application. We have a lot of components in that. So currently what we are doing is we are deploying all those services, right? All those microservices using Helm. Helm is like a package manager, right? We create packages for all our Docker containers, Helm packages for Docker containers, and then do the deployment using the pipeline. Yeah.
Oh, super cool. Thanks for sharing. So since you all have some experience with Kubernetes, now we can sort of move on and see some of the problems which I'm pretty sure you all must have faced as well. Yeah. So starting off with the first issue we would like to address. So since we author resources using YAML on top of Kubernetes, it becomes pretty important to ensure that our consumers who are consuming these YAML files and configurations to deploy resources authored by us on their environments are able to sort of configure the configurations which we are shipping according to their needs and use cases. So that's where it's sort of important for us to have like a parameterized manifest. The second point is defining interactions between the sources declaratively. So basically, the Kubernetes appeals to people a lot because there's this whole idea that once I've written my config, I can easily deploy it in any environment that's running a Kubernetes cluster, right? And it would be the best to get as much as I can done declaratively. Like instead of having maybe some controller or maybe some program that, or a bash script for that matter, which sort of programmatically, let's say, creates a resource, then waits for it to pop up and then creates another resource. You would rather just define interactions and relationships like these between the resources declaratively in your manifests when you're authoring them, so that it's good to go for the consumer once they're deploying it in their environments. So yeah, that's where the second point comes in. The third one is replicating workflows used while developing applications reliably. So so we are templating our manifest and we're defining relations among them. Then we're deploying it to our cluster. So we'll be using a bunch of tools, right? Like Girish mentioned that he's using Helm, and some people might be using Customize. And so you template your YAML files using one or multiple tools. You deploy it using a certain tool. You might be using a bunch of other tools to do some dynamic stuff with your YAML. And it gets important that the person who's consuming your application can get it up and running on their cluster as easily as possible and have the same effect as you did in your development workflow. So that's where the third point comes in. It's pretty important to replicate development workflows we have reliably on the cluster in production environments. The third one would be package and distribute different versions of such workflows. So now you have a workflow setup. Let's say it's a GitOps workflow, and you have shipped it to your consumer. Now maybe they have some feedback for you and you're making some changes to it. What you want to do is you want to have some means of creating different versions of such workflows and then shipping it to your users. So the user shouldn't be forced to move a version. The user should be able to pick a certain version of your workflow and then consume it. That brings us to a last point, ensuring immutability and consistency. So you have your manifests that are referring to some images. It's pretty important to make sure that when you're packaging your applications and when the users are consuming your applications, the manifests and images that are consumed are exactly the same as the time when you were packaging it, just to ensure consistency in the development workflow, in the production workflow, and even between different users who are consuming the same version of your package, right? So that's why it sort of becomes important to ensure immutability and consistency. So now we'll be sort of looking at certain tools that are part of the Carvel tool set, which address this. But before we get into that, we'll just give a short introduction of the tool set itself. So Carvel provides a set of tools that are really, each of the individual tools are really good at doing one thing. Like they do one thing really well. But when these tools are put together to create a development workflow, what we see is that it's an ideal tool set for managing your workloads on top of Kubernetes. And the cool part is if you use the Carvel tools to sort of build your development workflows, Carvel also provides a tool which can be installed on your cluster that lets you replicate these workflows reliably on your cluster. So this might be your own production environment, your consumer's production environment, yeah, and so on and so forth. So, and another cool thing about Carvel is that it's based on the UNIX philosophy, where as I said, each tool is really good at something, and these tools are composable. Like, so you can choose to use one of our tools, YTT, with one of our other tools, Cap, but you could also choose to use YTT and maybe kubectl, or let's say even Helm and Cap. Like, these tools are pretty, that's what we mean by composable. They can fit into your existing workflows pretty easily, and you can also pair them with other tools pretty easily. So now let's take a quick look at how our tools sort of address these problems, right? So what I'm going to describe over here is exactly what we'll be doing when we get to the hands-on part of the workshop. So yeah, so things might get much more clearer when we actually start doing these things, right? So the first part we discussed was authoring a parameterized and configurable package manifest, right? So, and the second point being define interactions between resources declaratively. So these two are addressed together by CAP and YTT. The idea is that CAP surfaces this API, which lets you define a certain ordering amongst the resources and even dependencies in that manner. Like, let's say you have a deployment which is consuming a secret, which has some sensitive credentials, right? And every time you update your secret, you have to restart your deployment. You can define such relationships declaratively in your config, and that's it. Once you deploy resources, your deployment is restarted every time you update your secret. You don't have to keep in mind that you have to do that. You can declare relationships like that declaratively in your YAML config. And YTT is a templating tool, which basically lets you sort of add the dynamic component to your manifests. You can use YTT to allow the user to supply certain values, which can be used to template your manifest. And what's unique about YTT and which sort of makes YTT different from other templating tools is that templating tools generally look at YAML as if they're text. Like, it'll be more like, okay, so at this line, I want to add this value that the user has provided. However, YTT looks at YAML like a data structure. So you can potentially do things like, okay, so if the user has supplied a list of values and this particular value exists in this list, then I want to add this key and value. So it sort of makes your manifests more dynamic and responsive, I would say. The third point, replicating workflows on top of production clusters, right? So Cap Controller is a tool which you can deploy to your cluster. And let's say you've built a workflow using YTT, Cap, and we'll discuss another tool later, Cable, right? So you will be doing certain steps using these tools when you're deploying your applications using your host, right? So what Cap Controller lets you do is it lets you create resources which sort of create a workflow template. You tell Cap Controller that to deploy this application, what you have to do is fetch the manifest from this location, template it using these tools, and then deploy it using Cap. And Cap Controller takes care of it. So it allows people consuming your config to easily deploy it into their environments. The third one is packaging and distributing different versions of such workflow. And the last point being ensuring immutability. So image package and Cable sort of work hand in hand with Cap Control over here. What Cable basically does is, so when we are referring to images, right? When we're referencing images in manifests, what we generally do is we use tags to decide which version of the image to use. And tags, however, are not immutable. We'll be getting more into that later on. So basically, Cable converts these references into immutable references. That means that reference can point to only one image. And what image package does is, image package, so we have two components here. There are your images and you have your config that's written in YAML, right? So we use Cable to ensure that our images are immutable because the references are immutable. So how do we ensure that the YAML config that we've written is immutable as well? So what image package does is it sort of creates an OCI image with your YAML files. It bundles your YAML files into an OCI image that can be pushed onto any image registry like Docker Hub, or maybe you all have Harbor running internally. So now that we have an image with all of our files in it, it can also be made immutable by cable, right? So yeah, that's how that's how all the tools fit in. And this workflow is going to be way easier to visualize once we actually get some hands-on, when we get to the hands-on part of the workshop, right? So I'm just going to go over the agenda of the workshop itself. So we're going to start off by authoring a config and then parameterizing using YTT. It's going to be a simple config for a straightforward application. And then we're going to use cap controller to replicate the workflow that we use to template and deploy the application reliably on the cluster. In the third part of the workshop, we'll start getting to the immutability part of it. We'll ensure that all of our resources can be accessed in a way where we ensure that the resources that we're accessing are the same as the ones we had at the time of packaging our applications. And then we'll learn how to version different workflows in our development environment so that they can be consumed. And then we'll quickly take a look at how this really helps your consumers, right? Like how doing this packaging your applications using these tools allows your consumers to get up and running with these applications quickly and configure them according to their needs, right? So before we jump into the hands-on part, so does anyone have any questions or thoughts so far? Did anyone want to share anything regarding the previous slide or this one?
So these tools, right, are those like available freely? Like, can be used in different environments or different clouds and all?
Yep. All these tools are completely free and open source, so you're completely free to use it in your own environments in whatever way you desire. Praveen, can you share the question?
Okay. So someone is asking, just curious to know if image package does the job equivalent to kpack from build packs for package management.
I am personally not very familiar with kpack does, what kpack does. So if you could share what kpack does, maybe.
Okay. So from what I understand, I think image package also provides an option to move OCA images from one place to another, or like, for example, you can move them from your local to a registry, or from a registry to local. So it helps in like also moving to air gap environments. So that's the like major difference that I can understand from looking at kpack. Just
Hi, Praveen. Hi, Shomik. So yeah, so just to be like, I just want to understand. So kpack basically is part of this Kubernetes container build service tool. So what it does basically is creates a complete OCI compliant image from source, right? So as I understand, kpack from the build pack ecosystem, it runs a complete lifecycle execution phase in creating that image. So I was just thinking, if image package does the same job, or is just push it or creates the OCI image and pushes to the registry? I mean, from the Carvel perspective.
It definitely does the former. And I'm guessing if you want to manage the entire life cycle of your application, you would have the freedom to choose another tool or choose another Carvel tool which addresses that.
Okay. I got it.
This ties into the UNIX philosophy we had, where each tool does one thing good, and you're free to compose these tools, right?
Okay. Yep. Thanks. Yep.
Before we jump into the hands-on part of it, I'm just going to share across a repository right now, and that repository basically it's like an overview of everything that we'll be going through in the workshop, and it'll really help you guys sort of follow along with us. So I'm going to share this link in the chat. Right. So before we get into the actual workshop, we'd just like to ensure that everyone has an access to an active Kubernetes cluster, which is up and running. And for the purpose of this tutorial, something like Minikube or Kind, which runs on your system, is just as good. that would definitely work out. So to just ensure that everyone's on the same page, can you all please just quickly open up your terminals and run kubectl API resources for me? So if you're able to see your API resources listed there, that means that we're good to go. So in this repo, we have most of the commands that we'll be executing. So you can easily copy them and paste them in your terminal so that you can keep up with us. And if we do execute something that is maybe not listed over here, we'll make it a point to sort of put down in the chat box, right? So to start off with, let's install the tools we were just talking about, right? So for people who are following along, you can either use the installation script that we have on the site to install all of the tools by running this command. Or if you prefer brew, you can go ahead and run these set of commands and tap into our home brew repo and just grab the CLIs. So I have the Carvel tools already set up on my cluster. Sorry, not my cluster, my system. And so, yep, I'm good to go. So if you all just, once you're done installing the tools, you all should be able to list the versions for cap, YTT, kbuild, and image package. Those are the tools we'll be primarily using. So the installation might take a while. So we're just gonna give a few minutes for everyone to get up to speed over here. So to start off with, all the resources that we'll be using in this workshop are available in this repo. So let's go ahead and sort of clone this repository on our systems. And after cloning the repositories, we need to get the product which helps us replicate these workflows on the cluster install, and that's cap controller. So to install cap controller, we're going to go ahead and run this command. Right. And so once you run this command, cap is going to sort of show you a list of resources that are being created on the cluster, and you can confirm them to go ahead and create these resources. So what cap does is it sort of waits for the resources to wait its desired state. So you should be good to go once you see succeeded when you run this command. And once the command succeeded, if you run cap list, you should be able to see KC installed on your cluster, and that's basically what we are trying to get up and running. So if I'm going to wait here for everyone to catch up over here, and then we can get started with the first part of the workshop. So if the installation is still going on, I believe in the next part of the workshop, we'll start off with sort of writing some manifests. So I think we can go ahead with it while the installation completes for other people. So Praveen, do you want to go ahead and start with that?
Sure. Thank you, Samik. All right. So we'll get started with chapter 1. And we are going to take a look at a very simple app. It's written in Go. What it does is it just starts a server on port 8081 and prints the message hello username. And username is something that we can provide by using an environment variable that's user underscore name. And what we have done is we have already Dockerized it and pushed the image to Docker Hub. And you can see that image over here. So this is the link for the image for the application that we are going to use for this session. Okay, so Now, once we have our application ready, what we would want to do is would want to like deploy it to our cluster. And like to deploy a service, we generally use deployments, and we will be using a service to communicate with the deployment. And we will be using a config map to sort of provide the environment variables that we would want to use in our application. So we have our deployment called simple server app, which will be having 3 replicas. And there are labels for label scoping. And then we have the image that is going to be used for the containers. And then we have our config map reference over here. And we have the username provided in the config map. And this is the service that we are going to use to communicate with our development. So some of you might have noticed that there is an annotation present over here. So actually a quick question for everyone over here. Like, are you guys familiar with what are annotations in Kubernetes? You can use the Zoom chat to share your answers. Metadata, that's good. Anyone else? Okay. So Giri, just like Giri has mentioned, we use annotations to sort of set some metadata for resources. We'll be talking in more detail about annotations at like later stage, and also about why we are using this annotation in a few minutes. Okay, all right. So let's go on to deploying our app. So one sec. So we would want to go to our starter config, and so we have our config.yaml over here, and now we are going to use cap to deploy it. Okay. So as you all can see over here, what cap does is it provides a basic summary of what are the changes it's going to make on the cluster. So it's going to create a config map, and it's going to wait for it to reconcile successfully. Then it's going to create deployment and a service, and again wait for reconciliation. Okay. Now, when we say and then it's waits for the user to confirm that we want to make the changes, and once we make the confirmation, it starts deploying. And the first thing that we can notice over here is that it tries to create the config map first, because what cap does is it groups resources and then orders them in a certain way. So for example, it tries to deploy the CRDs before CRs and namespaces before namespace resources, and resources like config maps and secrets, which are mostly used in deployments and services. So it creates the config map first, waits for it to reconcile, and then goes on to deploy the service and the deployment. And then it waits for all the pods to show up. So if we do kubectl get pods, we should be seeing three pods which are up and running for the simple server app. Does anyone have questions so far? So if there are some changes on the cluster after deployment, will it do the reconciliation? Depends on what kind of changes we are looking at. Like, let's say there is some mutating webhook which is going to make some changes afterwards, then probably not. But for example, over here, if the deployment is going to create a replica set and 3 other pods, then yes, I'll wait for all the child resources to be up and running. There are also like certain custom wait rules that we can add if we want to wait for some additional changes. Okay. We'll go to the next part then. So as we saw here, like there was a config map which was like using an environment variable which has the value of a username, and let's say we would want to sort of change it to something else, and so we would open our config.yaml, and let's say we want to, okay, we can actually like first take a look at what's our application showing us right now. So we would do kubectl port forward, and now if we go to localhost 8081, we see hello stranger, and the stranger is the value that we had provided in our config file. So now let's change this to, let's say, John Doe. And now when we do the deployment again, so okay, actually we can also use a flag call -c to which asks cap to show the diff between the current changes in the cluster and the one that we are trying to like make to it, have made to the manifest right now. So as you can notice, we made the change over here in the config map. We updated our username environment variable, and now now we would go back to like why did we use an annotation called version. So as you could remember, we had an annotation over here which says cap.k14s.io/version. Now what this does is it versions this resource, and now whenever we are trying to use this config map in a deployment, uh, it sort of like updates the deployment as well because the version has been updated for it. So if we take a look at this diff, it shows simple app config version 2 instead of version 1 because we have updated a value in the config map. So this I think is like one of the biggest problems that at least I had faced earlier when trying to deploy microservices, because whenever there was some values that could change in the config map, I had to like go and delete the pod or like do a redeployment of that the replica set. So CAP has like the solution for this problem. We can version the config maps or secrets, and the deployments that are referencing those secrets would automatically get redeployed. So now when we do this deployment, it will actually wait for all the pods to be up and running again. Our port forwarding might have stopped by now. I guess not yet. Okay, it's still working, but just to be on the safe side, let's do this. And let's see what. Great, the value has been updated now. Cool. Okay, so like we saw that cap is useful to like order resources in a certain manner. It does some sort of ordering automatically, and there are some annotations called change group and change rules which allow us to extend that to make some manual ordering of our own. And we have the version resource annotation to sort of make updates to reference deployments, etc. Cool. We'll move on to the next stage then. Okay. Yeah. Let's also try to like inspect the app So we created an app called Simple Server, which now Cap, what it does is it basically creates labels for all those resources that are part of this application. Another quick question for you guys. What are labels in Kubernetes and how are those different from annotations? Anyone? I have kind of like provided a hint. So for any changes in value, we have to update the camp deployment. Is it possible that this can be? Yes, it is possible in a way. We are actually going to look into that at a later stage. Labels target resources. Okay. Labels interpreted by K8s. Annotations are not. They are custom application specific. Okay. You can do selection on labels. Annotation are like properties. Yep, great. Cool. So like most of you have mentioned, labels and annotations both are used to set metadata for a resource. It's just that like Nipendra has mentioned, labels can be used for selection of resources. So we could like basically filter out resources among a list of resources using labels, while annotations could be used for let's say setting up a version for a resource, etc. So now we know that Cap is using labels for grouping resources. So when we try to inspect the list of the simple server app, we would see that there is a deployment, and then there are replica set and pods, and we have the config map and endpoint slices. So there are resources that are created by the cluster, which are the pods and the replica sets. But since those are like child resources of the deployment, those are also included in the application. However, the cluster would still own them. Okay. Let's move on to our next section then. So while taking a look at our deployment config, we could see that there are like bunch of duplications present over here, and there are also some configurations, configurable values that we would want to like maybe make them maybe like supply them in a more configurable way, let's say. So that's where YTT would come into picture, and YTT is basically YAML templating tool, which we would like see how it would help us to like reduce the redundancy and let's say provide the username and the port for us. Just give me a sec. We can use the load statement to kind of load the data model at the top of the config file, and then we would use a data value schema to like supply our like these are kind of the default values for our configurable values, which is the SVC port, app port, and username. So and then we would use this value schema with the load statement, load YTT data, and this is how we would like use it in the config file which we have right now, which is data.values.svc port and data.values.username. And then we could also see that there are labels which we have been using, and it's kind of being duplicated in a lot of places. So for the service, we would need it in the spec.selector field, and then same goes for deployment. We would need to have it in the spec.selector field, and this should be the same as spec.template.metadata.labels. So instead of like providing these labels at every place, we could define a function, which is let's say define labels, simple app, and then we could just call this function wherever we want to provide those values. So we do match labels, and labels, which this would basically provide all all the labels that are in this function to wherever we have used this wherever we have called this labels function. Now, if we kind of do YTT template -f dot is basically the current directory. So we would go to our config where we have these files. One is the config.yaml and the other is values schema.yaml. We can take a look at them over here. Config. So as you can see, we have the define labels function over here, which is being called out in the places where we wanted to have those labels. And then we are using the .src port to kind of provide the value of port over here. And same goes for username. So now if we would want to use FiTT on this, do some templating, we would see that all the labels have been added to wherever we wanted them to. And then we have also the username value updated, and the target port and port are also updated. So we could also like pipe YTT output through cap and do make the deployment using that. Also, the schema that we have provided is kind of the default values that we would want to have. If we want to override the default values, we can have data values, and we could provide those values over here. So if we could create a values.yaml with this, then it would replace the username with Zombik. Cool. We'll try to pipe the YTT output and make a deployment using cap. Great. And as you can see, I had provided -- yes over here, which basically asks cap to just continue without getting a confirmation from us. And it started the deployment and waited for the pods to come up and succeeded. We can try going to localhost and see if the values, we need to do the port forwarding again. Okay. Yep, the value is updated. Cool. Any questions so far? Okay, I see there are a few questions. I guess Renu and Tomic has answered them.
Hey, Praveen, if you want to address Girish's question as to what is the advantage of using CAP and YTT or Customize and Helm. I mean, we could keep talking about it. There are so many advantages, but if you could just quickly summarize the top few points.
Okay, what is the advantage of using CAP and YTT over Customize and Helm? Okay, so I'm not much familiar with Customize, but about cap, I would say, like, I guess I have already mentioned a few advantages, which is you get to see what are the changes that you are making. Like there is a transparency, which like increases the confidence. And then there are things like ordering, custom ordering, wait rules, and versioning of resources that would allow us to like deploy resources to like make the deployments updated when there are some changes detected. And yeah, Yash has also provided a video link, which you can definitely take a look at. It's Helm versus YTT and CAP. Is the templating syntax specific to YTT? Yeah, in a way, yes. Like as Samik has mentioned, YTT kind of passes your YAML as like a data structure, and it's not just like string replacement. So, Girish, to answer your question, I don't have like a very good use case in my mind to like kind of where data structure would be useful.
Two cases I can think of are, let's say, you want to template a resource based on a value provided by a user in a list, right? So you could do something like iterate over the list, over the values provided by the user, and then sort of template the rest of the manifest conditionally. And I'll definitely try and find an example of this if I can to help you out.
Examples would be good, but otherwise, like just like Samik has mentioned, it would be mostly useful when we are like looking at lists or maps that we want to update.
So this folder in that repository has like a bunch of examples in YTT being used in different scenarios as an overlaying tool, as a templating tool with or without conditions. How it processes user provided manifests and conditionally changes things up. So that you could definitely go through this repo for like more advanced examples.
There's also a playground available on the YTT on the Carvel.dev website, so you can definitely like try out a few things over there. There are like various examples provided over there as well to get started. All right, I am not seeing any other question which hasn't been answered yet. Or okay, this like a question: how does the custom values are overridden in case we have two values or YAML file in the directory? I think it would depend on which one got applied at the last, I guess. Okay, so we'd go to our chapter 2 now, replicating dev workflows in production clusters. So, okay, before we start this, another question for all of you, like, do you all know what are controllers in Kubernetes and how do they work? Like a one-liner answer would be more than enough. Reconciliation is done by controller. Okay. Anyone else? Setting a reconciliation loop in kth objects, bring different resources to the desired state in etcd. Great. Cool. We have got some great answers over here. So as you all have like mentioned, controller is basically, it sets a control loop in kth, wherein it's basically like a thermostat. So if like we set a temperature, it tries to like have that temperature maintained. So as soon as like it notices a difference in the temperature that has been provided and is there in the probe, it like increases the power output and brings the temperature to the desired state. So controller is something similar in kh. So it would work on at least one resource type or maybe more, and it would try to bring all the resources of that kind to like a desired state. So we have cap controller, which does something similar for app CRs, and app CRs is something that cap controller provides. So in one of the steps that Samik had provided initially, you would have installed cap controller using cap. Now we're going to take a look at what an app CR is. Like it's basically it defines three stages. Where can it fetch the required resources from? how it should template it, and how it should deploy it. So we have like created an app here for our purpose over here, which is named as Hello App. And then it uses a service account, which is default NSSA. It would create that default, create that service account as well. And then we have the first stage, which is where it should fetch the configuration from. We are going to use the configuration that we had just provided. So it's going to be the same repo that we are in right now. And it's going to fetch it from the main branch. And then it's going to use templating and using YTT. And we would want to, and this is like the path where the configuration would be located. So that's chapter 1/config. And then we are going to use cap to basically deploy our application. So if we go to here, I'll also delete the app that we were using earlier. Okay. So as you can see, even while deleting, it would wait for all the resources to get deleted and then succeed at the end. So now if we do cap list, we just have our cap controller installed. Okay. So let's go to chapter 2. We have our app over here. And now if we deploy that using cap.
Praveen, just a sec. Deploy the role bindings before.
Oh, sure.
Yeah.
So this is basically the service account that we are going to use over here. Cool. We have the service account role and role binding into the picture. Now we can go ahead and deploy our app. Great. So it'll deploy an app called Hello App and wait for it to reconcile. Cool. Okay. So we'll take a look at the app using kubectl. Get apps. And it says there is Hello App and says reconcile succeeded. So we can again like take a look at what's been provided. So we'll do this, do the port forwarding. And that's the value that is there in GitHub right now. Hello, stranger. Okay, now we can also talk about, there was one question like, what if there are some changes and we would want to like get those deployed as soon as like the changes are made. So that's where like cap controller comes into picture. So I have like a PR ready, which would basically change the value schema and make the default value to be KCD. And we are going to merge this PR to the main branch. And before that, we'll actually do a watch on kubectl get apps. It's in the reconcile succeeded state. And now we'll merge the pull request. Okay. So cap controller has like a default sync period, which I think is 10 seconds. And what it would do is it would fetch the resources again, and then do the templating and do the deployment if there are like any changes detected. Not sure if it has already done that, but we can take a look at. Okay, it hasn't done it yet.
I thought the default sync period is 10 minutes now.
The default is 30 seconds.
Okay, yeah.
So reconcile after 30 seconds.
But we could always override it with a value called sync period inside the app CR. Okay, I guess we need to start the port forwarding again. Cool, the value is updated. Can we use cap controller to target a specific namespace in a cluster or multiple? Yep, definitely. Okay, so like cap controller would basically like keep a watch on this app CR and try to like put it into the desired state every 30 seconds, or we could change the sync period to something else of whatever we would prefer. Yep, we can do cap list to kind of take. So we have our role bindings, the cap controller app, and then there is the hello app that we created. And then it also uses cap to like create another app called hello app CTRL, which would basically have all the resources that are there in the app. To the key cluster. Any questions so far? I'm pasting the link for the custom app over here, and which is basically fetching the app from the same repository and chapter 1 config. You can take a look at the app CR, the different stages of the app CR to like see how it does the fetch, like from where it fetches and what's the path for templating.
So let me quickly share my screen and we'll go ahead with it. So before we jump into the next part, a quick recap. We first started with a manifest which defined deployment, a service pointing to it, and a config map which is consumed by the deployment. We used YTT to sort of parameterize the configuration. Then we went ahead and deployed it with cap, right? And so then after that, we sort of used AppCR to replicate that same dev workflow on the cluster. Now, what we'll be doing is we'll be sort of moving towards the packaging part of things. Now, quick question for people here. What comes to your mind when we say packaging? Like in a general sense, it doesn't have to be specific to Kubernetes or anything like that. When you're packaging and versioning an application, what was the first thing from the top of your mind? RPM, okay. Deb and PM, right? So yeah, these are some package managers you generally using Linux systems. Yeah, it should handle all kinds of environments. Okay, a few responses. So something that's important when you're packaging an application is that, so the state of the application while you're packaging should be immutable and consistent. So when we talk about applications that we're deploying on top of Kubernetes, there are two parts to it, right? One, we have the images that are being referred to by the config, and then we have the config itself. So for chapter 3, what we'll do is we'll sort of first make sure that the images themselves are immutable, then go ahead and see how we can make our config immutable as well. To start off with, so we generally reference images using their tags, right? So for the simple server image that we've been using so far, it would be something like index.docker.io, pirava/simple server, and the tag is latest. So what happens here is another person might push an image with the latest tag, and your configuration, which is being consumed by your users, now are using a different image than what was used at the time of packaging the application. So we sort of want to make sure that the image which is being consumed by our packages are exactly the same. So that's why we would prefer to use another way of referencing images, and that is referencing it using its digest. So what we do is we ensure that each image that's being referenced by our configuration is in its digest form. So what the digest basically is, it's a SHA-256 hash of the image itself. So to put it into context, we always hash passwords before storing them, because for a particular password, there can only be one hash. And similarly, for a particular image, there can be only one hash that can refer to it. So let's jump into how Carvel handles this, right? So right now, I am in chapter 3. So for people following along, do hop into chapter 3. And I'm quickly gonna jump to starter config. So the config that we have over here is the same config that we had in the first chapter. It has the configuration that we templated using YTT and added some rules to using cap. So what I'm going to do is I'm quickly going to template it again. And we should be able to see the output in std out. So that's the templated image templated configuration we deployed last time. So now what we would want to do is we would like to ensure that all of the images that are being used are being referenced to using digest. So we quickly gonna pipe the output we receive from YTT template to kbuild and wait for the output. So as you can see, what kbuild did over here is it sort of replaced all of the images that were being referenced to its digest form. So now, let's say we're packaging this application right now, right? So now we're sure that if we give this package to someone, the image that is going to be used is going to be the exact image which we are using while we are packaging it. And so now that our images are in place, now that we are sure that our images are immutable, the next part would be to sort of make our manifest, the configuration that we've written, immutable as well. So to do that, we're going to use the tool image package. So also, if y'all are following along and you want to push your own image package bundles to your own repositories, make sure that you're logged into your Docker account, like you've run Docker login once, because image package is going to pick up that configuration, right? So to go ahead with the actual bundling of things. So the desired state here would be to bundle all of the files that we have in our config directory into one image that can be pushed to a registry. Before we do that, we want to let image package know about the references that we want our YAML to use, right? The image references that we just made immutable. So for that, we'll be sort of generating a log file, like similar to how npm generates a package log file, right? So what we're going to do is we're going to do the templating again, then pipe it into kbuild, and this time I'm going to specify an image log output. Okay, I do need to image. So this is actually a convention we follow while packaging images. The .image package folder will consist the lock information, which can be used to resolve images to their digests, right? And now what we can go ahead and do is we want it to be in .image package, and we can call the lock file images.yaml. Oh, my bad. It's image package lock output. Right. So we can see the same package, same output which we had last time while we were generating the digest. So if we take a quick look at what the image package file contains, right? Let's see, image package values.yaml. So this lock file over here basically tells image package that if you run into an image which has this URL, you can use this this digested URL to refer to it immutably, right? So now when we are building our bundle out of our configuration images, what we'll be doing is we'll be doing something like image package push, because we want to push our image itself to a registry, right? So we'll do image package push, name the bundle using the -b flag, and I'm going to call my image hello app repo, and then point it towards the config. So our config right now is in the config folder. So what it's going to do is it's going to take all the files that are present in config, create an image out of it, and push it to 100 mixage hello app repo. I can do it in the current directory. Right. So what has happened here is now this image will have all of my configuration that I was writing bundled into an image, and I can pull it and then consume it in whatever way I want to. So to quickly demonstrate that, I'm actually going to pull this image and put it in a temporary file, maybe kcdblr. And what's worth noting here is that the image package bundle itself is referred to using a hash. So it's immutable as well, right? So if I quickly see what is there in temp kcdblr, we see the same config that we had created earlier. And if you look at the config itself, all of the values, so the config itself has the templated values. It has all the values it needs to template the resources. And in addition to that, it'll have the image package log file, the image package log file, which sort of helps it to map images to a particular hash of that particular image, right? So at this stage, what we have is all the images that are immutable, and we have pushed all of our config bundled as an image, and the image reference itself is immutable as well. So before I move ahead, are there any questions that I can take? Why create an image for the config? How do we change the config per environment? Right. So when we get to the packaging part of it, right, I'm going to go over how users can configure the packaged YAMLs as well. So if you noted, I did point out that we're storing the templated manifest, right, in the bundle itself. So when the user installs the package, there's a way in which the user can apply their own data values to the package while installing it. So that's how the configuration part of it works. And so, yeah, that's all. And if you talk about changes across versions, you can have multiple versions of the same package, right? Does that answer your question, Girish? right? And it's worth noting that so when we bundled that image, right, it had a certain structure. The structure looked something like there's an image package directory with all the the digested references for the images. And then we had all our config, right? This config file can have multiple YAML files as well. So this, the format we just followed for the directory is something we call a package contents bundle. And how it becomes useful later on while we are making the packages is something that we'll get into soon. So if there aren't any more questions, I'm going to move on to the next part of the workshop where we actually package these immutable resources. So does anyone have any questions? Going once, going twice? Okay. I think we can go ahead with chapter 3. Right. So now that all of the resources that we want to package are immutable, what we want to do is we want to start with the process of creating a package itself. So let's quickly look at what a package looks like. Bring up. Go. Yeah. So a package, the first thing about a package is that you might have multiple versions of a package. And however, the different versions of the package will be associated with the same metadata, right? Like you might want to include information such as what the application does, a list of maintainers. You might want to mention how the users can find help. So the first thing we do is we sort of define a metadata config, which sort of tells the users what the package does. So as you can see here, what we're saying is we have a package called Hello App Corp. The display name for it is Hello App. It's a simple configurable app to demonstrate Carvel's packaging APIs. The short description says that it's a web server. It's provided by Carvel and we are the maintainers, right? So what this metadata will do is it will be associated with each version of the package, and it sort of helps packages have the same description across versions. For example, if you look at the package itself, we'll be referring to the package metadata YAML, from the package. And what you might notice is that the spec part of it, where we define what the package does, is pretty similar to the app CR we defined in chapter 2, right? So what we define while bundling a package is that where the package fetches its resources from, what it does with the resources that were fetched, and how the resources should be deployed onto the cluster, just as we did with our app CRs. So the main difference here you might notice is that we are mentioning an image package bundle instead of mentioning a Git resource. And that's because we want to ensure immutability, right? And this bundle over here is the same one that we produced in our previous chapter, where we sort of bundled all of our config and images and made sure that they're immutable. So the source being immutable, the next thing we'd like to do is template the configuration that we have. So we tell the package that once you have fetched the resources needed, you're going to go ahead and template it with YTT. And if you remember correctly, all of our resources are in the config directory, right? And we tell that after the resources have been templated using YTT, you go ahead and you use Cable to sort of ensure that all of the images are hashed. And over here, you might notice that we are passing the images log file to Cable, but we are also passing a dash. So what a dash means is, if you recall from the third chapter, while we were templating and piping the values into the different tools, we use a dash to represent that the value that will be used is the value that's passed on to the tool from the previous tool. We're basically piping the output of YTT to kbld. So that's exactly what we have tried to mention here declaratively. We have mentioned that YTT is going to template the config, and then kbld is going to take that information and use the log file to replace the image references with the immutable references, right? And then go ahead and deploy them using cap. So one thing that's, okay, any questions so far about how we are templating our dev workflow? Okay. So if there are no questions, we are going to go ahead and address Girish's questions, right? Like, how do our users, while consuming these packages, sort of configure the application? So while a user is installing an application, they can actually supply an open API schema of sorts, which defines the values that the user can configure. So if we go back to the value schema which we made in chapter 1, we have two values that can be configured. SVC port has a description. It's a number. Username is a string, and it has a description as well. So we put in this same information into our package, right? And yeah, so we basically say that these are the properties that the user can provide. We specify the type for each of those properties. We specify a description and like a default value for each of these values in case the user does not want to override it, right? So that's what a package looks like. So what I'm going to go on and do is I'm just going to deploy this package. So for that, we'll first move to chapter 3. Oh, sorry, 4. And if I were to use cap to deploy the package, as you can see, cap creates two resources. One of them is a package metadata, and one of them is a package. So what I'm going to do is I'm going to go ahead and not deploy these resources. And so the reason for that is when you are sort of delivering your packages to your users, we generally don't. So let's take an example of RPM or deb, right? If you're using deb, you would probably add something like EPEL, which is a repository of all the common packages that are used, right? And yeah, so if you're using npm, the go-to package is the npm modules repository that's there, and it has all sorts of packages that you can use. So when your user is consuming your packages, you sort of want to surface a certain repository, which lets the user grab all of your packages at once, right? So what we're going to do is we're going to create a repository that can sort of allow the user to consume the packages easily. Before we do that, do we have any questions about how packages and package metadata works? Just to reiterate over it once, we are defining how the package should deploy resources. Then we go ahead and provide a schema for the values the user can configure. We also provide a metadata that's common across all versions, and it can surface some information that the user might find useful. Okay, so if there are no questions, the next step for this would be to actually go ahead and create a repository for our packages, right? So for creating a repository, we don't have to write any YAML particularly. So if we go back to our previous chapter, we would recall that we used a certain format for defining our package contents repository. Like this is the like we sort of had a format where we had an image package folder with our image log file, and then we had a file with all of our configuration. So similarly, for creating a package repository, we have a directory structure which is similar to this. So the image package log file will have the image log file, which sort of maps every image that's consumed by the packages in the repository to its digest form. And the packages directory will have a folder dedicated to each one of your packages. since we only have one package, our directory is going to look something like this, and in the directory for the app itself, we store the metadata and the different versions of that app. So for now, we are going to go with just one version of the app. But in case we have multiple versions of the app, right, the repository looks something like this, right? So what I'm going to do is I'm quickly going to have a look at my repository. So as you can see, the repository has a packages directory, and it also has the image package folder that has been created here. And if I were to maybe look at what the image package folder consists of, I'm going to see into the repository package. So this is a log file which we can generate by using a cable, right? So if we were to do this again, we would do something like cable-f, and here we want to hash all of the images that are being used in your repository, used by all of the packages in your repository. So we mention that this is the folder where you can find all the image references, and then we go ahead and put the image package log output file in the directory, and we can call it values.yml. So, and if we look at so what we did now is we just generated the images YAML again, and it's the exact same. It has the immutable reference to the images that we're using, right? So we have our image package log file, which defines all of the images, the relation between the tag and digest for an image. And if we look at our packages, it has our hello app package, and that itself will contain the package file that we have written and the metadata file. So if we take a look at it over here, it has the package file, which we defined previously while we were authoring the package. And then it has the metadata file, which is the same one as the one which we made before. And it just defines a few metadata that the user might find useful, right? So now what we're going to do is we're going to go ahead and make an image package bundle for this repository. So I'm going to go one step back and do something like image package first. So for the repository, let's call the bundle something like hello app repo. And we can point it towards the files we'll be bundling, and that's repository, right? So the image that we have over here is basically an image of the repository, which means it has information about the packages. It has the metadata for the set of packages that we have there. It's basically everything you need to get your packages up and running bundled into one image, right? So I'm going to pause here and check if anyone has any questions. And after that, we're going to go ahead and look at how people would go about consuming these packages. So what we did is we created a package, we put the package in a repository, and now we're going to go ahead and consume it as a user would. If there are any questions, feel free to speak up, or you can put it down in the chat. Okay, can we store this package in GitHub? Yes, so you can definitely store the YAMLs you wrote for the packages in GitHub, and then those YAMLs can be bundled and move to a registry as and when they need to be consumed. But the answer to your question is definitely yes. You don't have to bundle it as an image package bundle. It can definitely be directly consumed as a YAML file. Like if you recall previously, I tried to deploy my packages using cap instead of bundling them into a repository. That's a definite possibility. Does that answer your question? Yeah. Okay. Cool. Right. So if there aren't any more questions, I think we're gonna go ahead and see how our users consume the packages, right? So you've put in the work, you've created a package out of your application, you've created a repository, and now you're ready to ship it to a user. So let's see how a user would go around about like consuming a package repo, so as to say. So for consuming a package repo, we'll be using the kctrl CLI, which sort of makes it easier for users to get up and running with packages super fast, right? So from our previous commands, we have a link to the image package bundle, which has all the information required for us to create a repository. So to get up and running with the repository, the user would do something like, we're going to call this repo hello repo, and we'll supply this URL to the user, right? Oh, my bad. It's kctrl package repo add, and we want to add hello repo. The URL is going to be this. So we're adding a package repo. The package repo is called hello repo, and kctrl will build the package repo using this image package URL. So now that the package repository has reconciled successfully, what we can do is we can go ahead and list the packages that are available on the cluster. So this is the package that we created previously. And so what the repository allowed the user to do is execute one straightforward simple command and add all of the packages that can be bundled as a part of that resource. I think there's a question. Okay, Zainu has a question for you all, so feel free to respond to that in the chat box. So yeah, so now that we enabled our users to sort of easily add packages to the cluster, let's see how a user would go ahead and install these packages, right? So once we have installed this package, the results should be the exact same as what we created when we were in the first chapter, right? Because that's the application that we bundled into a package. So the user would probably do something like kctrl package install, call the installation hello app. And so one thing is that we sort of want the user to be sure about which version they're using. So before going ahead and installing a package, the user can access more information about the package using the get command. The package name is hello app.corp.com. So here we can, so what happens here is this information is actually fetched from the metadata, right? And we are also listing all of the versions that are available on the cluster. And so let's say once the user has viewed this information, they want to go ahead and install version 1 onto their clusters. So that's when they do something like kctrl package install, calling the install hello app. We specify that the version we want to install is 1.0.0. And we'll specify the name of the package as well. That is hello app.corp.com. when a package is installed, what it basically does is it replicates the workflow that we had defined while creating it. How it should template the application, where should it get the image references from, and how it should deploy it, right? So if we were to run a cap list right now, we can see that there's an app called Hello App CTRL that's created, right? So let's go ahead and inspect this app. So as you can see, the resources that are created by this package once it's installed are the same as the ones that were created when we deployed our resources initially. And to verify, let's just port forward it once. So we're gonna port forward it and just open up our browsers to see if it's up and running. '81, right? Oh, we can see Hello Stranger. So now that we have a package up and running, we see how the user can install the package. One of the most important parts is how the user configures the packages, right? So let's get to that. So if you recall correctly, we also defined a schema for the values which can be supplied by the user. So we can actually view the values that can be configured by doing something like tctrl package available get. So since the values that can be supplied to a package can change over time and over versions, when we are getting the configurable values for a particular package, we also specify the version in this manner, and we supply the flag value schema. So over here, we can see that these are the two configurable values that we have. We can see their types, and we can see the effect they have on the package itself, right, when it's being installed. So what I'm going to do is I'm going to try to sort of change the username that's being consumed, maybe, right? So since this package is already installed, I'm going to update the existing installation with a new username. I'm quickly going to whip up a values.yaml file which supplies these values to the package. So let's say I want to change the username. So I would do something like username, and I'm going to put my name over here. And now what we want to do is we want our package install to consume these values instead of consuming the default values, right? So we're going to do kctrl package installed update. We called our application hello app, and we're going to supply a values file to it this time. So as you can see, the package reconciles again. So what the package install is going to do under the hood is that it's going to run that entire workflow, which we templated again. And it's also going to supply value/data to it. So if we quickly port forward again, and if we were to reload, as you can see, the package got configured, it picked up our values that we provided. And that's why it says hello Somic instead of saying hello stranger. So that's how the user can sort of configure the packages that we have while consuming them. So if we go back to the repository, we started off with an application. We replicated the dev workflow using an app CR, and then we built a package. We made sure the resources were immutable. We wrapped it in a package, and then we created a package repository which supplies that package. And then we sort of took the role of a consumer and went through how a consumer would consume such a package, right? So are there any questions regarding how the whole package creation and consumption process went through? Praveen, do you have anything to add to it?
I think there is a question, the last step of updating the packages. Okay. Compliment. Good. Actually, I would request anyone to everyone to ask their questions if they have any, or if you want us to explain any of the things, or if you are stuck somewhere, feel free to let us know and we'll help you out.
I do not think there are any further questions. Oh, I think Girish has a question. Are there any tools to do blue, green, or candy deployment? I'm actually not sure about that, but I think you can sort of define how you roll out your deployments declaratively while configuring your resources. Yeah, I think Kubernetes by default supports rolling updates. So if we don't have any further questions, y'all can access this repository at any point in time and go over the entire workflow that we just went over. It sort of actually guides you through all of the steps you have to sort of take to package that simple application and get it up and running as a package repository, and then on how to consume it. And so if you all do start using the Carvel tools, when you all start sort of building packages using Carvel tools, we would love to hear from you. We'd love to know how you're doing that. So you can join our Carvel Slack channel, which is on the Kubernetes workspace. And you can also find us on GitHub. If you have any issues regarding how you're using the Carvel tools, or if you have any suggestions that might help us improve on the Carvel tools, you could definitely raise an issue on our GitHub repositories. You can find the links to the same in the doc itself, like in the GitHub repo itself. And Renu just put in a link to our Slack channel. Please do join it and come say hi.